Welcome to the video on how to multiply matrices. So basically this video is going to involve processing two-dimensional arrays, and the multiplication of two-dimensional arrays is something that you need to put in your tool chest because matrix multiplication is an operation that is needed in a lot of applications. Games involve manipulating matrices, and you might not be aware of it, but there's a lot of algorithms that require matrix multiplication in a game, in a video game. So it's something that you need to know, and so we might as well tackle it right now and take a look at it. So here's the code that I have for matrix multiplication. You have a link to this code as well. So as you can see, I'm using my template, and so the idea here is there's my template. I basically have my global documentation, and the examples that I'm taking this particular my data from is from here. So you can copy and paste this into your browser, and they can give you a deeper understanding of how to do matrix multiplication. I'm going to describe it as well. So there's the basic template. Okay, we'll start at the process. So what we're going to do is read a data file. Right? I'm not going to type in a bunch of numbers. If you find you have to type in more than 4 numbers, then put those numbers in a file and read that file. So here's an example of a matrix right here. Okay, 2 rows, 3 columns. Here's another one. We're going to take this particular matrix and multiply that by another matrix that's 3 rows and 3 columns. Okay, so before we can even do multiplication, we need to read in that data. So let's take a look at how we do it. Well, I guess we'll enter the name of the first data file, prompt. I type in the name of the first data file. Okay, I pass into this to another method called read matrix, that name of the data file, and it's going to return a two-dimensional array. Just to prove that this thing works, I'm going to print out matrix A, and I'll put the matrix and put a new line. Basically do the same thing for the second matrix. Okay? And then, okay, so we'll assume that we have the 2 matrices in memory right here. We've got A and B, two-dimensional array. I'm going to pass that data to another method that takes those matrices, and it's going to return a two-dimensional array. I'll call it C. Now, if this thing returns null, that's basically going to indicate that you have a problem. Okay, something went wrong. So I'm going to output a little error message. Basically, the biggest problem that you can have is not counting the idea that you have bad data. Okay, like entering X for a number. The biggest thing is you have to make sure that the number of columns in the first array has to equal the number of rows in the second array. Otherwise, you can't do the multiplication. I'm going to show you that in a second. And so what I'm going to do is I'll put a little message here that says, hey, the number of rows, this right here is the number of columns. The number of columns in the first array, A, that's how you get the number of columns. We extract the 0th row, and the length of the 0th row, or the first row or the second row, whatever, but just typically use the 0th row, is going to be equal to the number of columns. The number of rows in the second row is just, the length of the B. Remember, two-dimensional arrays are arrays of arrays. So the first index would represent the row, the second index would represent the column, and an array of arrays, the very first index, the length of the very first index is the number of rows you have. So, okay, that's cool. We're going to go ahead and we're going to take that matrix and output it. Okay, so this is going to handle the output of the matrix. If it's null, it'll handle that as well. And I really think I should have done this. I forgot that I should have put an else there. I should have put an else there. See, that's good when we review our code. See, the idea here is I'm going to output this error message here. Actually, you know what? No. Let's leave. Okay, we'll do this. If C is equal to null, then we'll output the matrix. If it is equal to null, we'll output error messages. Otherwise, we output the matrix because it's a valid matrix. Now, I'm looking at this code, and you should be saying, hey, I see duplication of code here. See, this piece of code, these 6 lines are basically the same as these 6 lines. The only difference is I'm returning a different value for it. I'm taking the answer and returning a different value for that answer. And basically, I think we should probably make that. Whenever you find yourself duplicating code, you need to remove that duplication, because duplication is a cardinal sin in programming. So what I'm going to do is show you a neat little technique right here to make this code basically a method. It's not foolproof. You need to go through the code that it generates, but it's something that you should know about. It's called refactoring. So I right-clicked on that highlighted code, and somewhere in here there's got to be refactor right here, refactor, and extract that code as a method right there. So let's extract that code as a method. And it says its name is, the extracted code is called extracted. That's not a good name. That's not a good name at all. So what is that code doing over here? Well, what it's doing is get an output. Get an output a matrix. That's basically what it's doing. We might have to make some modifications. That's okay. But at least it knew that by looking at the code that you're getting its information from the scanner. See this SC, the scanner? Okay, it is getting this information from the scanner. And then we're going to have to take a look at how we have to modify that extracted code. Okay, look at what it did. Okay, look at what it did here. Okay, it created that matrix, and it said, well, the return value from that method is equal to a two-dimensional array. Okay, so why don't we take this code, because it's really in the wrong spot, let's move it up, cut, and put it into, say, right here. This is where you put all your methods in the templates. Okay, Control V. Okay, there's the deal. Now, how can we modify this code here? Because I'm calling this method, I'm going to call this method twice. Problem is, how does it change from one method to another? I think, here's the deal. What I'm going to do is say, well, see, the first prompt needs to change, because the first prompt would say data file 2, and then when I output the matrix, that's another prompt that needs to change. So I need to add a couple of parameters here that are strings. String prompt 1 and string prompt 2. Okay. And I'm going to call this prompt 1. Take it, come on. I can't grab it. Okay, there it is. Prompt 1. And this is going to be prompt 2. And then let's take a look at the code, prompt 2. And let's take a look at the code. So based on the prompts, I'll put the first prompt, read the file name from the scanner. Now we're going to look at this read matrix in a second. But assuming that works, I return the matrix and store it into a local variable A. Then I'm going to output that matrix, assuming that works. We're going to issue a new line and return that A. Okay, let's go back to the main program right over here. The main program says, okay, so what we're going to do is change this up a little bit. What we're going to say for the first prompt is enter, let's copy this. That's the first prompt, paste. call this prompt 1. Okay, and then the second prompt is what, matrix B? No, matrix A for the first matrix. Copy that, move this over here, and we'll call this matrix A. And so now we encapsulated all that code into one method, and basically what we need to do is copy this, copy, and paste this, call this B. Now they like to put their, I personally like to move my brackets to at the end of the variable, after the variable. Just looks better to me. Okay, so look at this. Let's change this parameter to 2, make this matrix B, and there you go. I think it should work. I don't know. We'll find out when we run the program. So we can get rid of this code. Look how much short. Look, by looking at that code, you know exactly what it's doing. Okay, and it's optimized for space. You don't even need this variable anymore. Okay, right there, nice and sweet. It works great. And then I wanted to show you something. You know what's always been a big pain with Java is that if you wanted to do multiple lines, if you wanted to output multiple lines, this is what you need to do. To create a string with multiple lines, you had to create one string and then concatenate it with the next string and issue your own new lines. Okay, no longer is that needed in Java 14. They have this thing called text blocks, and a text block basically, let me comment this out. So this multi-line string that I have here is something I'm going to put inside my formatter, because if something goes wrong, I would like to output a message that occupies that goes on 2 or more lines. So what I'm going to do is comment out this code, and you're going to notice it's basically the same string up top here, but there's no need to have to put new lines in there, because what the text block that they call it in Java 14 is delimited by 3 quotes. So we have starting 3 quotes, ending 3 quotes. Okay, you issue a new line, and everything in between those quotes is considered a string, and that this white space isn't included. Okay, so it's as if we did the same thing as what we have up here. It's a lot shorter and sweeter. We're going to show you that in a second. And okay, that's good. Let's go. Oh, I'm going to show you while we're here. Why don't I show you another neat little feature of Java 14, which you have to have Java 14, well, actually 13 or 14 for this to work. And that is, you can do something called, see how we had to specify the data type of A, because this thing is going to return a 2-dimensional array, and then I had to specify the data type to be 2 dimensions. I could have got away with simply saying this, var A, right there. I didn't need to specify the data type. Okay, this is something I think they call local variable type inference. What the system does is it looks at the data type being assigned. It knows that read matrix is going to return a 2-dimensional array, and why do I need to specify that A is a 2-dimensional array? That's what I'm assigning to it. So I'm assuming that I'm inferring that that is a 2-dimensional array, and it just simply works. That's a neat little feature. Something that I think you're going to use a lot. I'm starting to use this var a lot more in my programming as well. So that's a nice feature. What else can we talk? We haven't even talked about actual matrix multiplication here. Okay, so let me go ahead and run this and see if this thing works. I have a couple of data files. I showed you the data files. I need to specify. I put your data files in the same in your project. And if you don't specify any directories, it assumes this is in your project. So let's say call this matrix A.text. Oh, they read it. And look, the different prompt here, matrix B.text. And Okay, that's it. This is the answer right there. I don't want to do it again because I only have one set of data files, so that's fine. Let's see how we generate those numbers. So that's good. We showed you how to, they call refactoring the code here. Now, let's take a look at output. Output's actually easier to talk about here. If everything goes well, output, okay, we pass it the two-dimensional array here. All right. Listen, if the matrix is equal to 0, I mean, if the matrix is equal to null, if what you pass it is null, then we'll output null as well, and just quit. Okay, that's doing a little error checking on your parameters here. Just quit the program. Just quit the method. If matrix equal to null, return. If execution comes here, you know matrix is actually a two-dimensional array. So what we're going to do here is for every row that you have of your matrix, and for every row, take a look at every column of that matrix, and then output the particular element, row, column, in 5 spaces. This outputs one row of data, and this will output a carriage return after every row. That's the output method. Void method, it's okay. Now reading a matrix, let's take a look at read matrix. We haven't talked about reading matrix. Take a look at this. Now you're going to see something kind of foreign here. And remember, when you're reading a file, you have to handle that situation. It's something that needs to, remember you had to put a throws clause here. And there's 2 ways to handle a situation. You either put the throws clause, or you surround the possible offending code with a try-catch block. I chose not to do throws clauses because it turned out I would have to put a throws clause on every method up to and including the main method. And that's just a pain in the neck. So what we're going to do is say, for now, take on faith of what I'm doing here. Let's try this code. Because what happens is, if there's ever a problem, an exception gets thrown, and it's going to be caught by this particular piece of code right here. And then that'll be the case. Okay, so we'll try the code. If there's a problem, we're going to throw an exception, and that exception gets caught here. In other words, we handled it. And by default, this was something that was generated by, if I do a right click, and I guess there was a red mark on scanner F here. I said right click, generate a try catch to surround the code. And what I did was I just accepted that and accepted that this is the catch block. We're going to do much more with catches, try catches later on in the semester. But for now, what we're going to do is we create a file object out of the file name that we passed in. That's a string file name. We create a scanner. That scanner has nothing to do with the scanner that was created by the template, because this is a scanner that's connected to the file. And then from that file, we're going to read the first integer as the row, the second integer as the column. Remember, this is what we have. Row, column. Okay, we got that. And then what we've got is, let's create a matrix of that. Matrix of integers, row and columns, right there. And now for every row, for every column, read an integer into the particular element. Close the file, return the matrix. Okay, so if everything goes well, you're just going to follow right through, and that matrix that gets read from the file gets returned back to whoever called me. If there is a problem, we handled the error. Let's accept this code, but what gets returned is null, because after you catch it, you follow it right through. Okay, and this try block isn't going to continue on to line 82, because we returned the matrix, and whenever you return from a method, execution stops from that method. So I think this is a good piece of code. Now, the reason for what we're doing here is the actual matrix multiplication. Let's take a look at that, and then we'll be done with it. Now, you're going to need to understand how matrix multiplication works. You can either look at understand what I'm showing you here, or there's another video I'm posting that another professor describes the method. So I'm going to have you. I'll have you look at their or you can look at the actual URL that describes that I got these examples from. Either way, it's something you need to know. And let me try as best I can to show you what we're at, how to do matrix multiplication. Okay, so here's matrix A and here's matrix B. You've got to make sure that the number of columns in the first matrix equals the number of rows in the second matrix. The reason is, okay, there's 3 numbers here and 3 numbers here, so you need to multiply this number by this number, -4 times 1. So basically what you have here is, to get the answer, okay, you need to multiply, okay, the end answer is going to be 2 rows, there'll be 2 rows by 3 columns. Okay, this is a 2 by 3 matrix. Let me just fix this up a little bit. And this is a 3 by 3 matrix. 3 by 3 matrix. Okay, this is what we have here. These 2 numbers have to match up. Okay, the resulting matrix is going to be, if you remove those 2 numbers in between, is going to be a 2-row, 3-column answer. That's what we have for my output answer. To get what that first number is, okay, I set my row marker here, my column marker here. In other words, row is 0, column 0. So row 0, column 0, row 0, column 0 of my answer. This is my answer. I should call this C. C. That's going to be equal to -4 times 1. -4 times 1 plus, okay, now we go on to this next number, -1 times 6. So as we move along here, we find the corresponding element on the second element. That's why you need 3. If this is 3 elements in my for my columns, I have to have a matching 3 rows here. So I match up the first numbers, second numbers get multiplied. This is going to be -1 times 6. Then add to that 3 times 2, and that will give me the answer for that particular number in my answer. Now let's see. Let me show you what happens for, say we want this number here. The output answer is, by output is going to be C. C, row 1, column 2. What's that equal to? Row 1 is here. Column 2 is this column over here. And what I need to do is start multiplying the corresponding elements. 6 times 3. 6 times 3 plus 2 times 0. 2 times 0. So 6 times 3, 2 times 0, -3 times -3. And that should give me the end answer. Okay? So, let's see how we do this in code. Come over here. Okay, so we check to make sure the matrices are proper. Okay, columns must be columns in the first matrix have to equal the rows in the second matrix. And here, if it's not, we return null and stop the process. Okay, execution conditions are met. Let's create an array that is a.length in terms of the number of rows, and the number of columns is going to be the number of columns in the second row right here. So these are all a bunch of zeros, and now what I'm going to have is R and C visit every row and column of this output area. Okay, now you've seen that what happens is the answer is going to be a sum of a bunch of calculations, matching up every element of a column with every element of a row, multiplying them and adding them together. That's why we have a sum that will ultimately get assigned to the row and column of the output matrix. And I have another for loop that basically says, okay, for I is equal to 0 to, let's see, the length of the number of columns, say. All right. Perform this computation and add it to the sum. Okay. So this is A of R. Okay. Take that corresponding. Remember, we're gonna go through the R is fixed. We point to a row. We grab the ith element of that row, multiply that by, now C is fixed here to specify the column that we want, okay, but what happens is I now goes down and increments the row element of the second matrix. Grab those two numbers, multiply them, add them to the sum, and ultimately we'll get that matrix initialized with the proper value. Now, it's a little complicated, I know. Try your best to understand the algorithm. If my explanation wasn't adequate, then take a look at the other explanation that's on the website. You can go ahead and also look at the matrix that you have here, or the URL, and to take a look at that. The thing is, it's something that you need to know because it's an algorithm that's used a lot in gaming, and so you need to have that in your toolbox. All right, we'll see you in the next video. Take care.